Hello, everyone. I said hello, everyone. All right, thanks for coming here this afternoon. My name is Jimmy Bogard. You can find me on Twitter at @jbogard. And this presentation is on my GitHub at github.com/jbogard. There's a presentations repository. So all the code you see there from this and all my other presentations will be there. And I blog about this and a lot of other stuff on my blog at jimmybogard.com. All right, so this is a fun talk I like to do because a lot of teams I talk to meet that are kind of new to domain-driven design. They think that because they have an existing system or like existing code base that they can't possibly apply these domain-driven design principles to the code they already have. They think they need like a fresh, clean slate, greenfield application, and only then can they apply this kind of domain-driven design principles. But that's absolutely not the case. And so this talk is really about taking a code base that is not using domain-driven design and using refactoring techniques to slowly refactor it towards an actual domain model. But first, let's talk about what is domain-driven design. So the funny thing is that there's not actually a concise definition in the original book, so I had to kind of glean one from it. But it's a architectural design strategy in which we selectively distill, organize, and abstract the body of knowledge from the users to the software. Users could be, the product owners, it could be the other domain experts, or the actual users themselves. There's three kind of important parts of that. This is the distillation. So we're taking the complexities of the real world, and we're not trying to map the exact, down to the atom things that happen in the real world. Or if there's processes and stuff, we're not trying to capture every single step. So we're being selective about picking this part and this part and this part, and then explicitly modeling those concepts in the software that we build. And so a lot of domain-driven design revolves around this idea of an object model of the domain, and that's what a domain model is. This term actually predates the blue book, the big blue book of domain-driven design. One of the previous definitions came from Fowler's book, The Patterns of Enterprise Application Architecture. And he described it as an object model of the domain that incorporates both behavior and data. And those two parts are important. If it only had data, then it's just a data model. If it only had behavior, then it's just functions. And so the domain model in an object-oriented language needs to incorporate both things in order to be considered a, quote, domain model. Yes, but my existing code, it sucks. So how do we take the code that exists today and then try to represent this domain model idea in our actual code base? Well, one great way of doing this would be to use test-driven design that has these three steps of red, green, refactor. Or most legacy code bases that I see with little to no actual automated tests, it's more just we'll run it in production and then we'll get it working okay, but we'll just refactor right there. So looking at an existing code base, just figuring out how to refactor this safely and effectively, and also trying to understand, what's our end goal? What are we refactoring towards? There's a lot of great literature out there on how to perform these refactorings, and also a lot of great tooling as well. So we'll be standing on the shoulders of other giants of these different refactoring techniques that I did not make up, that are just already named out there, and they actually have nothing to do with domain-driven design. And a few of the books that I really like to refer back to for these kind of refactoring techniques. The first one is Michael Feather's great book, Working Effectively with Legacy Code. That's just another how can I refactor existing legacy code safely and add and make it testable as well? Of course, there's Martin Fallow's book, which has a second edition now, which covers a lot of refactoring techniques. And then my favorite patterns book is Joshua Karevsky's Refactoring to Patterns. So all of these look at all these kind of revolve around the same concept of I have some existing code that exhibits some kind of design or code smells, and here are some potential refactoring techniques to address those different code smells. Well, what we'll be doing is using these techniques to refactor an existing kind of procedural set of code towards an actual domain model. But first, let's look at the existing state of the code as it is today. So I've got here the class diagram of our current quote model. So one thing that is nice right now is that the names of these things do match the names the users use and the business experts use and the product owners use. So that's one good thing. I would say if you are in your existing systems and applications, the names don't match what the business uses and the names don't match what the users use, that is something to kind of try to address earlier than later, to say, can we at least agree upon the names of things, and then make sure the names of the things in our code also match the names of the things in the real world. So this code base is meant to model a loyalty reward system. And so in this loyalty reward system, you have people in the real world that can become a member of this loyalty reward system. So right away, we've got a class called member. So that's one good thing so far. It's not called person, it's not called human, it's not called human, I don't know. It's called member because it's not every single person in the world is considered a member of this loyalty reward system. So this is already like being selective about who we represent in the system. The attributes as part of that class correspond to the things that the business cares about, so the email and their name. And then it has a relationship over to this offer class. And an offer represents an individual like coupon or discount applied to a specific member. So an offer is tied directly to a single member. So if I am assigned a coupon or an offer and I get it scanned, then it's used and I can't, no one else can use it because it's specific to me. Finally, we have some administration of these different kinds of offers. And so we have this offer type class that has some kind of metadata information about the different kinds of offers I can assign. Now, if I look at the arrows between these things, they even represent the real relationships between these different kinds of objects. So member doesn't just have an offers property, it has an assigned offers property. The offer class itself doesn't have just a member property, it has the member assigned. So the name of it reflects the relationship between those two entities. So looking at this, though, there's something missing, which is the behavior. These classes only have properties and have no methods. I mean, they have, I guess, like the equals method, but that doesn't really count. It has no domain behavior associated with these different objects. So where is the behavior? The behavior does exist somewhere in the system, but where does it exist? Well, like it could be in the controller action, it could be in the click handler, it can be in like helper methods or helper classes or manager classes. So there's probably like a member manager, an offer manager, or offer helper. So these things, the behavior does exist in the system, but it's not reflected in those different domain objects. So in this case, I've got a services folder that contains all the different kinds of services that represent the different actions the user can perform related to these different entities. All right, so let's switch over to the code. So I'll stop sharing here and go over to Visual Studio. All right, so from here on out, we'll be just in Visual Studio using, again, these standard refactoring techniques to refactor this existing non-behavioral application to an actual, real domain model. Now, one thing you don't see here is a tests project. That was intentional because I was lazy and I didn't want to write tests. But in actuality, we should be writing tests along the way to make sure that the behaviors we're adding reflect the behaviors we're intending. But nothing like that for now. Okay, so I see down over here in the services folder, there's a few classes over here. And these represent the different actions the user can perform. I've got an assign offer handler, so that represents all the logic associated with assigning an offer to a member. And the next one I have is the expire offer handler. So that's the action that represents the expiration or expiring an offer for an individual member. And so if I look at these, I'll just pop up the assign offer handler. So the first thing I'll do when I look at any kind of class or any file to see like, well, what is this class doing? One of the first things I look at is just what are the different using statements we have here. And so right away I can see that we've got, it's using the services namespace here, so that's where the kind of DB context comes into play. It's got JSON stuff, so JSON and HTTP, so there must be some web API calls being made here. It's got threading because everything's async these days, so that's always going to be there. And it's also using mediator. This is not about that library, but it's also using that to represent an individual action. Now, this class takes a couple dependencies, so we can already see that it's using dependency injection. And inside its constructor dependencies, we can see that it takes an app DB context, so it must be doing some entity framework junk. And it takes an HTTP client, so it must be calling out to these web APIs. All right, so let's look, Lex, at the handle method. Okay, so it looks like the very first thing it does is it loads some data out of the database from entity framework. That's like most of the actions in an application. The first thing that happens is loading up some data. And then I see some code comments. So it looks like right away someone thought this code was too complex. So let's add some code comments to make it less complex, right? So it looks like the first step is then to calculate the offer value. And it looks like it's using a web API to do so. So it makes some API call to calculate offer value, passing in the member's email and the offer type. So those two things, like maybe there's some like calculations behind the scenes to say, oh, if you're a good member, then you get a higher discount. Or maybe it's like, maybe if you have more points or something, you can get a bigger discount as well. So it makes the API call, makes sure I got a successful status code, and then gets the value right after doing this deserialization. All right, next up we have is calculating the expiration date. So it looks like just a switch statement that's saying, depending on the offer expiration type, we're going to calculate the expiration date based on either, if it's an assignment type, it'll add days to today to say this is to give it an expiration date. So it'll look at the days valid. So if it's valid for 10 days or 15 days, it'll just add 10 days from today, and that's the date it expires. And the fixed type will just say adding days to the begin date. So the offer begins, like maybe it begins on May 1st, and it's good for the entire month of May, so that it ends on May 30th. 30 days, May, yes. And the final component is the actual kind of real work being done in this method, is to assign an offer to a method, or assign an offer to a member. So it creates the offer object, and then adds the offer to the assigned offers list on the member object. And then looks like here there are some calculated fields. In this application, maybe there's like a little summary widget at the top of the page, or maybe they do some reporting to sum up the number of active offers. So it looks like it's pre-calculating this number of active offers based on whenever someone modifies the assigned offers. Finally, it will add the offer to the offers DB set, so entity framework junk, and then finally save changes. Now, looking at this method, it's not like terrible. If someone on my team wrote this, I would probably be okay with the pull request. But that would be like a very short presentation, so I think we can do better. So let's look and see what different ways we can, what different techniques we can use to refactor this code. So the first thing I'm looking at is I've got code comments describing sections of code. So one of the first things we can do is to simply extract methods for each one of those blocks of things happening so that I have a better idea of like what that block of code is doing, what are the different parameters it's using, what data is it using, what data does it read, and what data does it write. So I'll just go here and say extract method. Yes. And the name of the method, let's see. Well, the code comment said calculate offer value. So that seems like a pretty good name for a method. So calculate offer value. It's telling me that it takes two parameters, the member and the offer type. Those seem okay to me. And so I will give it a name of calculate offer value. All right. We'll do the same thing for the next set of code here that's been commented out. So we'll extract a method here and say calculate expiration date. Extract method, calculate expiration date. And then finally, assign offer. assign offer. All right, so that looks a little bit better now. It reads more like a story, I guess. I've got the initial part that's loading the data. I've got the first method that calculates the offer value. I've got the next method that calculates the expiration dates. And finally, the last method that will assign the offer to the member. So this refactoring that I just did here is known as the composed method refactoring. The composed method refactoring takes a long method and breaks it up into a series of smaller methods in which each of those smaller methods has the same level of complexity or the same level of granularity. So I don't have like one method that's broken into like 16 methods. I just have like one method for kind of each of the main major steps that happen in this code. And this overall handle method right now is actually using another pattern from the Fowler book for patterns of enterprise application architecture. This is known as the transaction script pattern. Transaction script pattern is just this idea that I have individual actions for the different things that are happening in my application, and each of those different actions is represented by a single method that does all the work that is then wrapped in a transaction. So this is wrapped into transaction. I've got the save changes and the implicit transaction of entity framework. And then it just contains all the logic in a sort of procedural way right here. Now again, if I saw this in a pull request, I still might accept it and say, well, that's clean enough for me. I can read the different steps in each of these. And if I want to see the details behind them, I can go to the individual methods and look for the details there. But again, that would be a very short presentation and not very fun, so let's keep going. So the next thing I'll do is look at each of these individual methods, look at what logic is inside of there, and try to figure out, should that logic belong somewhere else? So let's get the first one, calculate offer value. All right, so this method, the first thing I see is that it's not static. It's an instance method. And that what that clues me into is that because the services or the dependencies of this class are also instance fields, because it did not refactor into a static method, that means that it's using those dependencies in some way. And sure enough, we see right here, it is using this HTTP client dependency. Now, looking at this right here, if I wanted to add a test to test out this logic and behavior, well, this is going to be a problem, right? It's calling out to some web service, and as the code exists right now, it is more difficult to sort of mock or fake that call out. So what I'd like to do instead is refactor this method and extract it into a separate class. And by the way, I am using ReSharper here, and that's I don't get any like kickbacks from them or anything like that. I've just been using ReSharper for like ever, so it's just a bit easier for me to use those tools. And the other thing that is a bit different from ReSharper, there are going to be some refactoring techniques I'll show you that don't exist in any other like free tool that you could use, whether it's Roslyn extensions or anything like that. And I'll highlight those when I get to them, but those are the ones that I leverage a more powerful tool in order to be able to do those more interesting refactorings. So let's then extract this, and I'm going to extract a class. And so we're going to extract a class, and first we have to give it a name. And this one says the method name is calculate offer value. And so if I want to turn that into kind of a name of something that, or the name of the responsibility of this, I could call it the offer value calculator. So let's call it that. Offer value calculator. It has a little red here and says it needs to figure out how to get this HTTP client dependency. And so I'm going to tell it to do is, let's see, I can give it that object as its own dependency. So I've moved that field from the source class to the target class. And the next thing it says is I need to make this method public because it's private right now, so let's go ahead and do that. I'll click next, leave it in the same file, and let's see what happened. So we see that method just disappeared here. It's gone. And where it put it is over here at the top of this file. So here we have now an offer value calculator with a dependency on an HTTP client. And then the behavior of this is the exact behavior we saw before. So it does the var response equals blah, 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 call the API, deserialize the, read the content, deserialize the content, and then return the value. So exact same thing it did before, just bloop, extract it into a class, and put it in the same file here. Now over in my initial class, we can see that this is instantiating now the offer value calculator directly inside of this constructor here. So we're still not at our testable state. So if we want to get to a testable state, we'll have to have an interface for this in order to be able to mock it out in our unit tests, the unit tests that don't exist. So again, I'm going to put my little caret on top of this calculate offer value method. I'm going to say extract interface. And now it's going to it's going to tell me a name. It's going to give it a name of offer value calculator. That seems reasonable. And it's going to ask which members I want to extract. And so just that one sounds good. Hit next. And now we have an offer value calculator interface with this single implementation of the offer value calculator. Now, I don't like that name of that class. I don't like implementations of an interface that just drop the I. That doesn't give me any hint or clue about how this class implements that interface or what it's doing behind the scenes. So we're going to rename this class to Web Service Offer Value Calculator. We won't rename the related symbols because who cares? And there we go. All right, so now we have a web service offer value calculator that implements this interface. Now, because I've got, we'll get there in a second here. Okay, so back over here, I still don't have a testable interface here. So I will put my little caret over here and say, refactor this. And down here, there's a use base type where possible. So what this is doing is saying, I'm using a more derived type. If I look at all the usages of this type, can I use the base type instead? And so what I wanted to do is to examine all those use cases and say, am I using the class methods or am I using the interface methods? And this is a safe way for us to then perform that refactoring. So use base type where possible, and then not system.object, that would be silly, the interface. And then there we go. It just changed that into an interface versus the type. Now, I could have done that myself, right? I could have just hit backspace, 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 and then and then see if it compiled. But by using the tool, it's a little bit smarter and more intelligent about analyzing the usages of it. And so it's a safer change versus just kind of manually editing the code. All right, the last thing I want to do is, it's still not unit testable because it just directly puts in this HTTP client. So I'm going to say I want to refactor this, and I want to introduce a parameter for this thing that is the offer value calculator, and it also tells me this parameter can be safely removed. So let's do that. Remove the HTTP client parameter, and now I just have the offer value calculator. Next. Okay, now this is a warning because we're using dependency injection and there are no unit tests, that it says there are no usages of this new constructor that you're telling me to do. And so you'll probably have to go fix that somehow. So it's just giving me a little warning here. I hit next, and then, oops, it did not do that right. Initialize field, there we go. The tool's not exactly perfect all the time, so we have to fix up little things. No big deal. Okay, so we introduced this interface. First we extracted a method into its own class. So that is the extract method into class refactoring. We introduced an interface for that one method. We modified all of our usages in this class to use the interface instead of the instance, instead of the derived type. And the very last thing we need to do is fix up the dependency injection junk because something has to inject this dependency. That is going to be the DI container. So over here on, let's see, startup services dot add HTTP client, It'll be the offer value calculator, and the derive type is going to be the web service offer value calculator. And then I would then, inside of here, need to give it the URL to wherever that is. But this is all made up and make-believe, so there's no URL there. Okay. So what we've introduced here, though, is a domain service. So this service does some domain calculation, and it's interacting with our domain model in order to perform this calculation. But if I looked at that method to understand, like, where should this logic belong, the way I'll determine that is to look at this method and say, what are the primary objects that it's interacting with? And so if I look at this method, I'll first look at the first parameter and say, what is using this? And I just see that, well, it's really just the pulling out the email property here, but that's about it. It's not interacting with anything else on that member object. What about offer type? It's only this offer type .name property that it's accessing over here. So if I'm looking at this method and trying to figure out where should this logic and behavior go, it could either go in the member object, the offer type object, probably not the cancellation token again, that's silly, or just some other class. And because this method is not primarily dealing with just one of these objects, it's just like it's dealing with both of them equally, then neither of those are a good candidate for where this logic should belong. And also it's primarily just calling a web service. So because it doesn't primarily deal with any of those, either those domain objects, those entities, then extracting this out into its own class is the next best thing. Okay, so far we haven't really refactored anything into a domain model, although domain services are part of the model, so that's not exactly true. But so I mean, it's still not exactly that interesting. So looking at these next two methods, at this point I'm like, I don't know where all of this logic should belong, so maybe let's apply some defactoring to put the logic back into this method so we can see the bigger picture. Now I do this all the time. I don't just refactor my code, I also defactor my code. So if I'm even trying to understand a new code base for the first time and it's very heavily factored, one of the first things I'll do is defactor that to put all the logic back into one place to see what's going on, and then I'll hit git reset and then put it back to where it was before. So let's do that here. Let's defactor these two methods. So I'll go to this one and I'll say inline this method. Inline all usages, yes. It didn't understand how to do the state expiring thing, so I'm going to just inline that as well. Let's see, let's refactor this and say let's inline that variable and then rename this to date expiring the way it was before. Okay, so I defactored that method. Let's defactor the second method. Control-Alt-N to inline the method and get it back to where it was before. Same kind of issue we saw earlier, in that it has preserved that variable reference for whatever reason, and so I'm going to inline this again. I could ask the JetBrains people why it does this, but again, I'm lazy about things like that. All right, so now we've kind of got things back to where they were before, of all the logic, except for this external dependency, is now back in this one single method. And I like to use this technique a lot just to kind of take a step back and say, okay, what is this? What is all this stuff doing? To try to see kind of the forest for the trees, that is. Well, one of the first things that I can see here is that it's got a little green line under there telling me that it can simplify the switch statement. And so I'm on a newer version of C#, and so it can actually change that to a switch expression. So that already looks a bit better. And so now I've got this calculating the expiration date and assigning of the offer. So looking at each of these, this expiration one first, if I'm looking at that set of code, I'm looking at where is a good place for this kind of logic to belong. And looking at this logic, I can extract that method again just to see what it looks like. And I can see that it is just taking the offer type as an input and having the date expiration as an output. And the method itself is static, which means there are no dependencies. So that could tell me that a good place for this logic could be on this offer type object itself. So let's do that. I'm going to refactor this method. Oh, first, let's change the name. Calculate expiration date. And refactor this to move this to another type. Now, I'm going to cheat here, though, because there's an even more powerful refactoring technique than this one. Way down here, there's another refactoring option here to say, make this method non-static. Now, that refactoring will look and see that this method is static. And so if I want to make the method non-static, then that method needs to belong to some instance. And so when I do this method refactoring, it's going to ask me, okay, if I'm going to make it non-static, what instance parameter do you want to move this method to? And the input is the offer type object. And so I'm going to go ahead and say, yes, make that method non-static and move it over to the offer type object itself. So now, over here, I've got a calculate expiration date method, but notice it no longer uses the, it doesn't go offer type dot expiration type. Instead, what it's doing is that it converted all those usages of calling into the object's properties and instead replaces them with the instance properties. So that is pretty neat. I'm actually going to inline that and make this an expression bodied statement because why not? Now, if I looked at this as well and saying, well, where else could this logic possibly belong? I could say, well, it's kind of equally dealing with the offer type object and the expiration type object. However, expiration type is an enum, and enums are just fancy ints. They don't get behavior. And so sometimes what I'll do is create a class around this enumeration, and like Java has these, they have enum classes. But that can be a bit of a pain for like persistence scenarios and things like that. So I'm just going to leave it alone and say, you know, even though that set of logic may be better in here in the expiration type enum, because it's not a class, I can't move that behavior over there. All right. So let's go back over to the assign offer handler. And so I've got this date expiring, and then I have the assigning the offer. So I'm going to do the same thing again. I'm going to extract this into a method with the intent of seeing what are the inputs and what are the outputs. So extract a method, call it assign offer. And again, we see, wait a second, this method is static. So it means that this method is not using any dependencies in this handler class. That's a good thing. That means that I can move it somewhere else without worrying about having the dependencies having to come along for the ride. So I'll do the same thing we did with the last one, which is to look at the usages of each of these values and try to figure out, is there are one of these a good candidate to move this method into? So let's go one by one. I've got the member parameter. So looking at usages, looks like I got 1, 2, 3 usages of member. Looking at offer type, just one usage down here where it's just setting the property. And then finally, int value. I mean, we don't own that type. We're probably not going to move behavior into the int class, even though they might let us do that with their new C# 11 stuff. But that's not a very good candidate, so we're just going to leave that alone. And then the same thing with date expiring. It's just that by itself. So I'm going to refactor this and making this method non-static. Because member seemed like had the most stuff going on, let's go ahead and extract this method and move it into the member object. So what's going to happen though is everywhere you see member, it's going to either put this or just take it off. So right here, it'll be replaced with this, and then these two usages down here, it will just remove them. So I'll go next. There, away goes the method, and then over on our member object, now we see, here's our assign offer method, taking in the offer type, taking in the value, and taking in the date expiring. Now going back to my handler class, I kind of thought it was a bit strange that this calculate expiration date was outside of the assign offer method. And the other thing that's kind of weird is that this date expiring is derived from the offer type. So right now, this assign offer method, its parameters say, give me an offer type, give me the value, and also give me the date it expires. So this could be like date time dot max value, could be date time dot min value, it could be yesterday. So it's not kind of fully encapsulating the logic of how should it calculate the expiration date. Does that belong to the member object to know for itself? Like I know how to calculate the expiration date or who to rely on. I don't want you to just give me any expiration date. That's my responsibility. So undo, put the date expiring back. All right, so what we're going to do is in this assign offer method, I'm going to inline this parameter. And inlining the parameter will look for all the usages of someone calling into that method and then offer those as potential candidates for using that as a value instead. Now, if this had like 1,000 usages, I may be like, oh, that's too many. Maybe this class doesn't have that responsibility because there's too much variability. But if I look for usages of this, because we have no unit tests, there's just this one single usage in my application. So I'm going to refactor this parameter. I'm going to say inline this parameter. It's going to use this date time from date expiring, and it's going to get rid of this date expiring. Now hit next, and here we go. Oops, that didn't do what I wanted. Control Alt N, inline that. Yes, parameter removed. Don't add that parameter. There we go. Okay, and so this one now, instead of being date expiring, instead that should be offer type dot calculate expiration date. And so now over in my usage of the offer handler, I no longer need this calculate expiration date, so I can go ahead and get rid of that. Now there's another way of doing this. If I go back over to member and I could undo and put this back on there, I can go back over to my object over here and I can say, let's go ahead and inline this parameter. And so it just passes that in right there. And now when I go ahead and inline this parameter here, inline parameter, there we go. That's what I wanted to do the first time, but I forgot to inline the first one over there. Okay, so it saw that the one usage I had in here was me passing through that value, and so it says, okay, I'll go ahead and use that value as, or use that expression as the thing I'm going to use to calculate the expiration date. So, I think I can actually get rid of some code comments now because they're not really adding anything of value here. So let's go to that and get rid of that. Okay, so now what I have is a single call out to that interface to calculate the offer value, and then a single call over to my domain object to then actually assign the offer to the menu, to the member based on that value that I calculated earlier. So this, I think, is pretty good right now because it's got most of the behavior of assigning the offer inside the actual domain object itself, and it's fully encapsulated that entire operation. Now, one thing we could do, and I'll try it, and I think about half of you will hate it, so that's fine, it's perfectly fine, is if I look at this member object now, it's still being able to get any kind of value being passed in. And so it's still not telling the caller of this that, you can't just pass me any value. You need to give me an offer value calculator because that is really the thing I need to use in order to calculate this offer value. I don't want you to just be able to do whatever you want. So if we want to do that refactoring, I will inline this value. Now it has await calculate offer value in there. And if I go to the assign offer method, I can also then inline this value as well. It will add these two parameters, the offer value calculator and a cancellation token. And now this needs to be an async task of offer because it has to await the calculation of that offer value. So now we've got var offer equals member.assign offer, but actually need to await this over here as well. So I'll say await member.assign offer. And now, instead of us passing through just any old value, what it's doing is saying, you need to give me an offer value calculator, and that's the thing I need to use in order to calculate the offer value, not just any value that you want to pass in through there. And so now that it's made that dependency explicit, saying, me as a domain object, I rely on this other domain service in order to perform my work. But because we don't have dependency injection, that's okay. We'll just pass in the dependency as a method parameter. And so this code is still unit testable. It still doesn't have any quote dependencies on external services because it's that interface. The only wonky thing about this is that it's got async in a domain model. And that's usually where like half the people will kind of like feel sick and want to throw up because like async in a domain model, that seems kind of odd. But in any case, this pattern is known as the double dispatch pattern. The double dispatch pattern is often used in domain models where perhaps the logic of performing this business logic is pretty complex. And so I want to put that business logic inside of the domain model, but there's just like one or two little parts where it has to reach out into some external service. And then perhaps there's some interplay between the business logic and calling things and whatever. And so this provides a nice way of still preserving this encapsulated domain model, but being able to pass through dependencies still behind an interface as method parameters. Again, like half my teams like this, about half the teams absolutely hate it. So I just want to throw it up there as like, it's a possibility, but if your team doesn't like it, that's fine. Just pass in the value like we did earlier, no big deal. All right, so at this point, it is like fully refactored from a transaction script, and I've now pushed all of my behavior down into this domain object. However much you may not like that one part. We're not done yet. If I'm looking at my domain model, it lets people do a lot more things than it should allow. So if I wanted to do something like member.assignedOffers.clear, that would give the product owners a conniption fit. They would freak out because they're like, you can't just clear out someone's offers because some of them are still good and they'll complain and they'll go try to use some coupon and it says offer not valid anymore. But nothing in our domain model makes that explicit or clear that you shouldn't be able to do this, but the API does let us do this. We can also do things like var member2 equals new member, and then we just don't have to give it anything. So if I went to the business and said, okay, so I got this member object, it's got these four parameters, but those properties don't have any values, is that okay? Again, they would not be okay with that. Because like for them, there are some critical pieces of information that make this object a quote member versus just like any other object or any other like person walking off the street. So I go up to them and ask them, like, what are the things that if you took one of these things away, it would no longer be that thing? And you can kind of think of it as like, what makes a zebra a zebra? If you take the stripes away from a zebra, is it still a zebra? I guess if there's stripeless zebras, maybe, I don't know. But it would be like a horse, I guess. And so it's the same kind of thing that I look at each of these properties and say, which of these properties are absolutely required for this to be a thing? And if I took any one of those away, it would no longer be that thing. And those are known as invariants. Invariants are the things that if I took anything away, it would no longer be that thing. It's also known as like these business rules that are always held to be true, and so we need to preserve them. So if I go over to the member object, so the problem is that it's just got a public no-org constructor generated by the compiler, and lets anyone create anything and set absolutely anything anytime they want. So let's fix that. Let's create a constructor that includes those invariants, which are the first name, the last name, and the email. I'll hit finish. And now it has set those individual properties. Now there's some other problems with this code, because if I go over to the member object, let's not do that. I can still do something like member.firstname equals null. And that again is not something the business probably wants us to do. And so I'd want to go through those different operations and say, okay, what are the use cases that we have for changing this information? And then let's make those use cases explicit as individual methods. So what I'd like to do instead is say, private sets, don't let anyone access this, private sets, private sets. We ask the business, is it okay for them to change this information? And they say yes, they can change their first name, they can change their last name, but they can't change their email. I just made that up, let's just pretend that's the case. So now what I'm going to do is create a method that allows someone to change their first name and last name. So I'm going to create a method that's just public void change name, and they can pass in the first name, and last name. And as part of that, we're going to set the first name and last name property. Nope. I thought it would just do it automatically for me. That would have been nice. First name equals first name, and then last name equals last name. And then if we were on the very newest version of C#, we could do something like a bang, bang, bang operator, I think, and it would do the argument null exception thing. We're not yet, or if that even is going to make it in the feature, or in the next version of C#. So what I want to do here is check to see if these are null or empty. Oh, look at that. Tab. If strings are null or empty, throw, oh, look at that. It's very smart. Tab. Yes. Yes. Okay. By the way, that is the Microsoft Code Assist, the AI service that will do that magic for you. It's kind of like the GitHub thing as well. That was not planned, but I just saw that it came up. I'm like, oh, that's exactly what I want. Thank you. Okay, in any case, now I have encapsulated the operation of changing the name of this member, and it's now enforcing those invariants and saying, if you give me blank or null names, I'm not going to allow that. I'm going to throw an exception. Now, there probably is a screen behind this that allows a member to change their name, so I still expect that screen to have that sort of validation. And so this is just kind of the last resort that says, I'm going to protect my, my aggregates invariants by making sure that those invariants are always enforced. Okay, let's go back over here. And the other thing we were looking at was the member could just clear off the list of offers. And so we don't want anyone to just be able to do anything to that list. So what I'd like to do instead is encapsulate those collections. So instead of having this public list of assigned offers, instead what I'd like to do is say, I will only expose out the operations that I will allow you to perform and nothing else. So, look at this. Target type new. There we go. Okay, so the way we can examine this is I can refactor on the list type and say use base type where possible. And I'm going to I want to select the most protected kind of base type. And for me, that could either be a read-only collection, maybe there's some stuff there, or just IEnumerable. Let's go with maybe read-only list or IEnumerable, maybe just IEnumerable. Let's just do that. However, nothing happened. And that's because it couldn't perform that refactoring. Something else is still using that list. So if I go over here and say, let's go ahead and make this, let's cheat IEnumerable of offer, okay? And now this needs to go back to what it was before, new list of offer. And the next thing we want to do though, is we want to, let's see, over here, to property with backing field. Get assigned offers, set assigned offers, and probably make this a private set because we don't want people to just do whatever they want. Okay, so by making that a private field, it means that down here, I can't just go off the list of assigned, the public property anymore. I got to go to the private field, and now this should be a list of offer. There we go. And this right here, I think we just want to get rid of this. We don't want to allow anyone to set it, so it'll just be a get only property. Now, depending on your ORM of choice, this may not be possible. I'm pretty sure EF Core allows you to do this, of having a backing field with the actual type it needs to be, in this case, a list. But it's something you want to check to see, is that possible? And you may have to kind of mold or shape how this is getting encapsulated based on what is actually possible in your ORM of choice, if this object is what gets persisted directly with your ORM. Okay, so we cheated. This code compiles, and if I compile the whole code base, I did not put on the turbo button to make this go fast. Oh, build succeeded. Wait a second. That's not correct. Because if I go over to my other handler here, app.members, assigned offers, a single default. Oh, I forgot the other one. Yes, okay. There's another one I wanted to fix here, which was over in my assigned offer handler, I could do something like member.assign number of active offers equals int.max value. You've got all the offers, all of them. But that doesn't make a lot of sense. Neither does having a negative value there either. So the problem is I'm still allowing anyone to be able to change this value. So what I'd like to do is go over to the number of active offers property and make this setter private. I've made the other setters private, but I haven't fixed this one, so let's go ahead and fix this one. So I can put a little private there. This code still succeeds. Now if I compile, oh, there we go. That's what I was looking for. The property or indexer of number of active offers cannot be used in this context because the setter is inaccessible. So, sad trombone. Okay, that's not something that's not insurmountable. So what I'd like to do is do the same refactoring to this method that we just previously did on the last method, which is to extract, first look at this class and see what is it doing. It looks like it's also using that transaction script pattern, so it's loading up some data, performing some operations on that data, and then saving the data, all in one single method. So I probably won't extract methods for the getting of the data and the saving of the data. That's not very interesting. This is the actual interesting part, the middle. So if I extract that method, and let's see, what is this doing? This is expire offer handler, so this is probably going to be expire offer. Next. All right, so it's still not compiling, but that's okay. We're going to put this in the right place to make sure that it can actually access that property. One other thing here, it's using this request object. I don't necessarily want to use that as a candidate for where this behavior should lie. So if I'm looking at each of these objects, it says, each of the parameter inputs has got this request object and member. But that request object is kind of throwing me off here. So let's actually go over to this request offer ID. I'm going to introduce a parameter for that. Replace two occurrences with offer ID. And it's also telling me that it can safely remove this request object as a parameter because it's just not using it anymore. So I'll click next. And now if I go back, I can see what's being passed in. It's passing in the request.offerID. And then down here, it's now just a GUID. So again, let's look to see which one of these objects should I now now extract this logic into. Should it go into one of the input parameters, one of the other objects that's being used in here, or another class entirely? So if I look at the usages of each of these parameters, I see 3 usages of the member object. I see 1 usage of offer ID, but again, that's one of our primitive types, so that's not a candidate for us to move that logic to. But another valid one we can look at is this offer object down here. I see 2 usages of that. So 3 of the member, I think. Oh, no, just 2. So 2 of the offer, 2 of the member. But it looks like it's using member first. It uses member to go and find the offer it's interested in. So let's go ahead and extract or make this method non-static and move it to the member method. That was a mouthful. So refactor, make method non-static, select the instance parameter member, next. Aha! So now this transaction script method is now nice and clean. Load the data, delegate to the domain model, and then save the data. Now, if I go look at my expire offer method, it's compiling again because now it can actually mutate the number of active offers because it's a private setter, and I can access that private setter from this instance method. All right. Nope, we don't want that. All right, so where do we wind up here? So we get this assign offer method that takes the offer value calculator and the offer type. Oh, but here's another one of those problems where it's got just a bunch of things that are publicly set, and I won't be able to actually use those. So this would be another candidate for us to look at how can we encapsulate the creation of this offer object. And again, it's just got a bunch of public setters. So what I'd like to do is talk to the business and ask them, okay, which one of these can I take away and it would no longer be an offer? And looking at these, they need all four of those properties. If I took away the member, an offer is not an offer unless it's assigned to a member. That's kind of a requirement for this system. I do need to know what the type of the offer is in order to have other logic associated. I have to have an expiration date. We don't have offers that can expire at the heat death of the universe. And there has to be a value for that offer as well. So all of these things. So let's create a constructor that includes all of those different values. Oh, check parameters for null? Sure. All right. And now we can make all of these setters private. Private, private, to private, to private. I can also make those init-only properties. There are some issues with that, so I'm just going to leave it alone. I still prefer private setters for domain models. Now, I do also ask the business, can you change any of these values once an offer has been assigned? And they say no. You cannot change anything. I cannot reassign offers. I cannot change the type of the offer. I cannot change the expiration date. I can only create new offers that have a new expiration date. I can't do anything with the old ones. Actually, that's not true. I can expire. In any case, let's go back over to, okay, so this code no longer compiles. And so I'm going to need to call that constructor with all the different values. So I've got member assigned is now this, right there, offer type, and then the await thing, I'm now regretting that, var value, there we go. That was the expiration date, so that's the offer type.calculate expiration date. And then finally, the value. All right, and now I can get rid of all of that. All right, so I passed in the parameter for this offer type.calculate expiration date. That looks a bit odd. It's passing the offer type and then also calling another method immediately. So let's fix that. I'll go over here and I'm going to inline that parameter, the date expiring, and then next. And now let's replace that usage with the one place it found calling it type.calculate expiration date. I will leave the value alone because you can't have async constructors and it would be too painful to try to push that down, so let's just not do that. And so now over here, I've got calculate the offer value, instance the offer with those different values, and then it's done. So now at this point, my invariants are now enforced on the offer object itself, that it's not allowing you to change any of these after the object has been created. Oh, but there's some red down here. Oh, you can change the expiration date. So yeah, that was another feature that the business needed, is that if they accidentally assigned too many offers to people or someone did some fraudulent thing, they would expire the offer, which just would set the expiration date to today, so you couldn't use it anymore. So we actually need to extract a method, expire, and this should not be a questiony one. That should be just regular one. There we go. And then what we'll do is refactor this to make this method non-static, moving it over to the offer object, and now it just says offer.expire. So at this point, my domain model, the offer entity, now fully encapsulates any behavior associated with the date expiring. So our initial transaction script methods had all of the logic associated with the domain inside of that single method. And what we've done is use these standard code smells and standard refactoring techniques to refactor this code, but with a goal or with a direction in mind. we're trying to refactor this towards a domain model. And so what I'm doing is preferring moving these methods into those domain models itself as opposed to other helper, manager, whatever classes. And really that's kind of the big difference between like object-oriented code that is still like not using domain models. That behavior exists in your application somewhere, but it's just not inside of those objects. And domain-driven design is about having those behavioral models that enforce their own invariants. They enforce their own business rules. And so by having those domain models enforce their own business rules, we ensure that these domain models don't get, quote, invalid at any point in time. All right, I think I feel pretty good about this. Do y'all feel okay about this? Maybe minus this right there. Yeah, that's fine. All right, so that was, going back to my presentation, that was domain-driven refactoring. We pushed our behavior into our domain model using these standard refactoring techniques that have been well documented well before, many years ago, even decades ago now. And so if you have a code base that has maybe all the names of things aren't quite there, but your behavior is scattered across your whole application, these techniques can help you build a domain model by just using these kind of regular standard refactoring techniques. So thank you very much. If you have any questions about this, I'll be hanging around afterwards, or you can find me on Slack. Otherwise, have a great rest of the conference, and yeah, thanks.